Hi, and welcome to Module 10 of Lecture 1. Now we're going to turn to measurement or operationalization. Once we have our theory and our hypotheses, we need to start thinking of how to test them. Since the hypothesis is a testable statement derived from theory that indicates a cause and effect between two concepts, we need to actually go about testing the hypothesis. The theory is an abstract level, remember, but the hypothesis is an empirical level, and therefore we should be able to test that the empirical statement is true or false. Okay. To do that, we have to be able to measure our theoretical concepts of interest, right? Our DV, our dependent variable, all of our controls, in order to test for suspected cause and effect in our hypotheses. Without good measurement, all of our inference is suspect, right? We can't test our theory accurately because we might not be measuring the things in our theory that we think matter, right? It's all well and good to form very carefully designed causal connections in your theory and then create a nice series of hypotheses from that theory that are all testable and falsifiable in a great way and have a nice research design that controls for all sorts of threats to inference. But if you then go measure your independent variable in a way that doesn't capture your concept, your entire test isn't worth much. So we're going to focus on measurement now for the next few modules. Okay, so how do I go about measuring things? It's very tricky, right? And this is an area in which really showcases why social science in many ways is much more difficult than other sciences that have more clear measurement, right? If you want to understand growth, there's different, more clear ways to understand growth, physical growth. If you want to understand movement or time elapsed, there are ways to do this that are reasonably agreed upon, whereas understanding things like democracy or opinion are necessarily much fuzzier and require a lot more care taken in developing good conceptual definitions and then good empirical definitions. So our start, as always, is to begin with a good theoretical understanding of our phenomenon of interest, right? And to construct from this a good theoretical definition of our concepts. Once we have a good theoretical definition, we can use that to develop the operational definition, right? The operational definition helps explain what the concept looks like and how it can be measured in the empirical world as opposed to the theoretical world, right? And to do this, we can often look at what other people have done before us to see how they measured this concept and see if that also fits our concept of the concept, right? We're going to want valid measures, reliable measures, and unbiased measures, which we'll talk about in the next module. But for now, let's do some examples to get a sense of how measurement actually works in practice. And we'll start with the idea of environmental protection as a concept, right? Let's say we have some theories that are involved in environmental protection. But how do we measure it? Well, again, the first step is to have a good, thorough theoretical understanding of our concept before we can measure it. So what precisely are we talking about here, right? How can we measure the concept of environmental protection? What is it? What are we looking for? Right? What do we mean by environmental protection on a conceptual level? And then once we know what we mean, what is the best measure for that? So let's use some examples here. Two possible ways to measure this are very different. One is measurement of environmental protection via legislation or policy. The idea being the concept of environmental protection suggests a polity, a people, a government that puts weight on the protection of the environment and therefore enacts policy designed to protect the environment. The measurement, if your conceptual definition of environmental protection is policy related or legislation related, measurement will all relate to the policies that have been passed or raised at least, right? So things like restrictions on leaded gasoline or being a signatory to international environmental treaties or restrictions on CO2 emissions, right? All these things relate to policies that a government may pass or at least bring up and potentially pass that help mitigate the effect of damages to the environment. So it's more of a forward-looking policy preference measure of environmental protection. That could be what you're looking for, in which case those kind of measures would be accurate, and what you would do if you want to measure the concept of environmental protection with that conceptual definition would be to either pick one or more of these, or to construct some kind of composite index of multiple policies that have been passed to give you some sense of the overall preferences of the legislature or the population towards environmental protection. But you may have a very different idea of environmental protection in your mind conceptually, it might refer more towards performance, right? The outcomes, what's actually happening with the environment right now. And in that case, measurement would involve things like the level of air pollution at the moment, the actual level of CO2 emissions in the air, the area of preserved land within a country, the number of endangered species in that country. That's trickier to measure. So all these things get at how the environment actually is, right? So if your conceptual definition here is not about policy or preference, but rather about outcomes and what the world actually looks like in terms of the environment, you want to use one or more of these measures, or again, some kind of composite index of multiple measures. Okay. And this matters a lot. Measurement in general matters a lot. And here's an example. Let's say your hypothesis you're trying to test is that democracies do a better job of environmental protection. Well, an earlier study found that democracies do a better job in terms of protected land area. There's more protected land area in democracies than non-democracies, indicating that if your measure of environmental protection is protected land area, then you support your hypothesis. Great. However, if you're looking at measures that involve deforestation, carbon dioxide emissions, or soil erosion by water, democracies do worse. Right? So in that case, if those are your measures, you'd find your hypothesis not supported. So it's a completely different outcome based on how you choose to measure it. And finally, if you want to measure environmental protection based on freshwater availability or soil erosion by chemicals, then democracy has no significant effect. So again, how you evaluate your theory depends completely on how you measure your concepts. So matching your measurement to your conceptual ideas is extremely important. And it comes up a lot in political science. There are entire subfields devoted to better measurements of important concepts like democracy or public opinion, right? So measurement is extremely important. In general, your goal is to have, and to make it easier for yourself, your goal is to have very clear definitions of the characteristics and boundaries of your concept or construct of interest, right? You want to know exactly what you're talking about and what you mean by it, not just sort of the common usage words. Exactly what you mean by it, and write it out very clearly before even trying to get what measurement would be applicable. To do that, you need to know your unit of interest. We're talking about measurement at the individual level, at the state level, at the country level, and how those things vary. Are they varying over time or between units, right? Time series or cross sections, right? And overall, be very, very precise. It's very important to have a very clear conceptual definition before you start figuring out which measurements might be the best for your particular concept. I'll conclude with the last example. Participation. Let's say you're interested in explaining public participation in politics, right? Participation here is your construct of interest. So the first step is to construct a good theoretical definition. Right? You want to define the characteristics and boundaries of the concept or construct. Right? So the concept of participation here may be defined as the extent to which individuals in some electorate participate directly in the election of the representatives. Right? That's our concept. That's not the only concept in the slightest. It turns out there's many, many ways to participate, as you might imagine, and different types of participation might be correlated in different ways with different independent variables, and in fact are, empirically. So measuring participation is not at all obvious. This is just one of many possible cases. The key is the one you want to use is the one you care about. So if this is what you care about for participation, you must state it clearly and upfront, so everyone knows what you're talking about, so they know your measure should match the thing you're thinking of and not what they're thinking of potentially. Once you have this good, clear theoretical definition, you want to operationalize it. In this case, we might operationalize participation as a percentage of a state's voting age population that turned out to vote for the highest office in the most recent statewide election. Again, just as there are many concepts, for this particular concept, there are many measurements possible. This chooses a particular election both temporally, like the most recent one, as opposed to like a time series of all elections to see like the pattern. And it also focuses only on the highest office as opposed to other offices, which is important because typically the highest office gets more interest, right? Presidential election years have more turnout usually than midterm election years because there's sort of more at stake, it's thought. So again, construct a good theoretical definition, then operationalize your theoretical constructs. Next time we'll discuss more about reliability and validity and so on.